of your Chapter 5 Time Value of Money lecture. I break them up a little bit to make it a little less long for you. So the first part of that lecture, we were dealing with your solving for your period, for your interest rate, for your present value, your annuity, and your future value. Now we're going to get into uneven cash flow streams. We are going to get into calculating your effective annual return, and then we're also going to talk about amortization tables. So it gets a little bit more complex from here on out. I'm hoping to make this a bit more simple for you and easier to understand. So we ended with slide 24 that was talking about our 20-year-old and our 40-year-old. Now we're going to start at slide 25. So what we're trying to find out here is what is the present value of an uneven cash flow stream. So here we have that nice little timeline again. We have a timeline of 4 years at a rate of 4%, and we have all these different, annuity streams. So we have $100, we have $300, $300, and -$50. So this is an annuity stream, just like we were talking about earlier. The only thing that makes it different is that it is an uneven annuity or cash flow stream, essentially. So here, this lecture displays that we can take $100 and today we can find out what the value of that $100 is. So I could go to my calculator here on the right, and what I could do is I could say, okay, I could individually discount each of these cash flow streams. So you'll notice again that word discounting comes up, and like I said in the previous lecture, we're taking a value in the future and we're finding out what it's worth today. Therefore, we're discounting or going backwards, taking a future value and finding the present value of it. So what they've done in this slide here is they've shown you we can find the present value of each of these individual cash flow streams. So I'll show you the first one just for reference. If I wanted to find out what the value of $100 is, I know that in 1 year, so my N is 1, that I'm going to have $100. I know that I'm investing it at a rate of 4%, so I'm going to plug in 4 for my IY. I'm trying to find my present value, so I'm going to go ahead and skip over that input. While this is an annuity, because we're solving for it individually, this $100, which in a previous question would have been the payment, actually becomes the future value in this question. So let me say that again. I know that this stream is technically an annuity stream, so your first instinct might be to take this $100 and plug it in for the payment. But because we are solving for this $100 individually and we're trying to find its, present value, that payment actually is the future value. So we're going to go ahead and put in 0 for the payment, and then we're going to go ahead and put in $100 for that future value. And if we compute, we will have that present value of $96.15. Okay, so again, remember that present value is negative because technically if I look at this on an individual level, I would have to get that $100 in a year, I'd have to invest or what is worth $96.15 today. So you could do that for each of these cash flow streams, just like I did there for year 1. And when you find the present value of all of these cash flow streams, if we add them up, what we find out is that the present value of this entire cash flow stream after we've discounted it is $597.48. So a pretty tedious process. The nice part about this nice BA2 Plus calculator that we have is that we already have a cash flow function in the calculator. So if we go to slide 26 here, we, instead of individually discounting each of those streams of cash flow, we're going to use what we call the cash flow or the cash flow register in your calculator. So let's go ahead and walk through this question. So in slide 26, they've taken this nice timeline and they've basically converted it in slide 26 into this cash flow register for you. So let's go ahead and learn how to use the cash flow register. So let's come to the right and look at our calculator. So again, because they haven't told you that this is an annuity due, we know that this is an ordinary annuity, so our calculator needs to be in end mode, and it is. Sorry about that. So it is up here because we don't have anything in the upper right-hand corner. So we have this function right here called CF, and that's cash flow. So we're going to press that, okay? So when you first start using your calculator, you can arrow down through this function and you'll see that everything's set at 0, okay? And that's what we want it to be set at. To clear your cash flow register, you click second, clear time value of money, clear work, okay? And that'll clear the whole register for you. So let's start with the first input here. So from that timeline, today we know cash flow sub-0, remember sub-0 means today, we have $0. So if we go to our calculator, cash flow sub-0 is always entered as 0. So we're just going to leave that as 0, okay? So we know that it, because we have the equal sign there, that number is in an input for cash flow sub-0. So we're going to arrow down, and it's going to bring us to cash flow in year 1. So the CO1 means cash flow in year 1. So if we come back to our lecture here, on the PowerPoint, we know that in year 1, we're going to have $100. So to input this into our calculator, we're going to type in 100. And then, this is a little bit different than the previous input. We're going to type in 100, and then we're going to click Enter. Okay? So previously, you were typing in the number and then hitting the input. Here, you're going to go to the input, you're going to plug in the number, and then you're going to hit Enter. Okay? And so you're just going to arrow down through this cash flow register. So let's arrow down. So instead of having cash flow 2 pop up, what we have is we have frequency 1. And what this is, it's asking how many times did cash flow 1, or how many times does this $100 repeat itself, okay? So in this instance, we know, let's look at cash flow year number 2, it's 300, so we know that that $100 never repeats itself, so our frequency is 1. It only happens 1 time, okay? So we're going to go ahead and arrow down to cash flow year 2. So we're going to go ahead and plug in 300 and hit Enter. And then we're going to arrow down, and for the sake of this, the frequency on cash flow year 2 is technically 2, because if you look at cash flow year 3, it's also 300, but just for the simplicity of this example, I'm just going to act like the frequency is 1. Here, if you're a more intermediate user of this calculator, you could plug in a frequency of 2 here in year 2. If you're comfortable doing that, it doesn't adjust your years for you, so just make sure if you're comfortable doing that, that you understand that. But for right now, for simplicity's sake, let's just arrow down to cash flow year 3, so it's 300, so we'll plug that in. And for simplicity, we'll just put a frequency of 1 in there. And then we'll also arrow down to cash flow in year 4, and that is negative 50. And so the same rule applies as previous. You'll plug in 50, negative, and then you'll hit Enter for a cash flow in year 4 of negative $50. So you'll notice that there are more than 4 years of cash flow. If you scroll through this calculator, you can, through the register, you can scroll back through and make sure that all your inputs are right before you continue on. So, you know, we don't have a cash flow in year 5, it's 0, the frequencies are 0, that's all good and well. You don't need to adjust that. So we'll go back here, and after we've put all of our inputs in and our frequencies are correct, we're going to press this button called NPV, and that stands for net present value. And what it's going to bring you to is an interest rate of 4, and that was previously plugged in. Yours should say 0, but in this question we're using a rate of 4%, so it's saying we are investing this money at a rate of 4%, so you'd plug in 4 and hit Enter. Again, mine's already entered in there, yours should not be. And then what you're going to do is you're going to arrow down one more time, and it's going to bring you to this net present value screen, and you'll notice that that says 0, okay? So what we're trying to find, just like we did in the timeline in slide 25, is we're trying to find out what is the net present value of this cash flow stream. So to find that, we just click Compute, and what you'll find is that same figure, that 597.48, that we also had here on slide 25. Okay, so on a test, I mean, this is good practice here to solve the problem this way by individually discounting each cash flow stream, but on a test, you'll want to be very comfortable with that cash flow register and just use the register to solve the problem. So essentially what we solved here is, of this uneven cash flow stream, today we know that the present value is $597.48. People get confused with present value and net present value. They're the same thing. The only thing that NPV, or net present value, means is that we have multiple cash flow streams, and it is the net, or the sum of those cash flow streams. So let's go to slide 27. So again, like I said, annuities always get more complicated. They're the most complicated piece in this class. So let's look at something different than an annual period. So we've been dealing with an annual period this whole time. Straightforward, super simple. Year 1, year 2, year 3. But it says, will the future value of a lump sum be larger or smaller if it's compounded more often if I hold my interest rate constant? So if you have the same interest rate, but you're compounding more often, you'd be correct in your thinking that you would earn more money. And that's correct because you have more compounding periods. So if we look here, let's just simply break this timeline down. What this timeline is saying right here is if I take $100, and again, this timeline is an ordinary annuity because it's happening at the end. If I take this $100 at the end of every single period and I compound it for 3 years, my future value is going to be $112.49, okay? But let's assume instead of taking that $100 every year sitting in my account or my savings account, and instead of compounding it annually, I compound it semi-annually. So if we look at the second timeline down here, you'll see that we have semi-annual periods here. And semi-annual means twice a year, right? So we have our year 1, year 2, year 3 in the second timeline, but you'll notice instead of having 3 periods like we do in the first, now we have 6. And you'll notice that instead, if we compound for 3 years and instead we compound for 6 periods instead of 3 periods, our future value of this $100 is worth $112.62 instead of $112.49. So again, if you compound more, the more money you earn, okay? And I think previously I said that this was an annuity. I'm sorry, that's not an annuity. It's just $100 that you're investing for 3 years, okay? So what happened here? What caused this semi-annual amount, future value, to be worth more than this annual amount? Well, we know it's because we compounded more frequently. Well, lucky for you, there is an equation that we use to solve this. So that nominal rate, you'll see here on slide 28, we have this thing called the nominal rate or the annual rate that ignores any kind of compounding effect more than annually, okay? So you're going to start to see this figure called I-nom, and all that means is a nominal interest rate, okay? So if we go back to slide 27 here, this 10% here that they compounded annually, that is the nominal rate. It ignores all other compounding effects down here. The other term that you're going to start to see is what we call the periodic rate, and this is the amount of interest charged each period. So here in slide 27, I'm going to switch back. This 10% was our nominal rate that ignored compounding, and this 5% right here is what we call that periodic rate because it takes into effect compounding, okay? So after having said all that, what does that mean? Well, what we're trying to figure out here is we're trying to calculate our effective annual return. So when you're working through these questions, guys, if you have a question that says, indicates that there's an interest rate, anything that's other than an annual rate, you know that you're going to have to use this calculation. If it says it needs to be a semi-annual rate, it's a quarterly rate, you know that you can't just use the nominal rate anymore. You guys are going to have to use what we call EAR, or the effective annual rate. So let's just simply break down what this effective annual rate, or as your book refers to it, this EFF, effective, or effective annual rate. Let's just go ahead and break down this calculation. So to calculate this rate, I have to introduce a couple new inputs to you. And they're actually not new, you just knew them by a different name. And this is one thing that you guys are going to learn in this class, is that the vocab changes from chapter to chapter. It's all the same time value of money concept, but the vocab's going to change because we're going to start changing the dynamics in which we calculate, and we're also going to start changing the assets in which we're calculating. So that's for a later lecture. So our effective annual rate, so the equation is 1 plus our I nom, or our nominal rate, divided by M, okay? So the nominal rate here in this question, it says, what is the effective rate for 4% semi-annual interest, okay? So we know that we have to use year here because this isn't an annual rate anymore, it's semi-annual, okay? So the nominal rate is 4%. It's our annual rate. It doesn't take into consideration compounding. The M in this question is our period. So on your calculator, you knew it as N, as in Nancy, and in the effective annual rate calculation, you now know it as M, as in Mary, okay? So if I'm compounding semi-annually, it means I'm compounding twice a year, so my M is 2, okay? So I'm going to take that M, and I'm going to close off my equation, and I'm going to take it to the power of my M. So that's also 2, and then I'm going to subtract 1. So what you notice from this calculation is that my nominal rate, or my annual rate, is 4%, but my semi-annual rate, because I'm compounding twice in the year, is now worth 4.04%, because I'm earning just a little bit more because I'm compounding more often. So it's just as straightforward as that. So and down here they have a good bullet. The annual interest rate, I'm receiving 4%, but the semi-annual compounding, I'm receiving 4.04%. Okay? So let's skip down to slide 31 here. And I like this visual because it helps you understand, again, the power of compounding. Again, the more often you compound, the more money you will earn. So we have that effective annual rate. That's the annual rate, or just simply your I nom, your nominal rate, was that 4%. And if you follow that same equation from slide 29 back here, if you plug in the M, the varying M, you're going to go ahead and get these equations, or these interest rates, excuse me. So if it's a semi-annual rate, your M will be 2, and your rate will be 4.04. If it's quarterly, your M, you would plug into that calculation, would be 4, and your effective annual rate would then be 4.06. If it was monthly, your M would be 12. If it was daily, your M would be 365. So really the only thing that's changing in that equation, your nominal rate of 4% stays the same, but your compounding period changes, okay? So again, just displaying the more often you compound, the most beneficial thing I could possibly do here is take a rate, a daily rate that compounds daily, because I would earn 4.08% instead of earning 4%, okay? So the more you compound, the more you earn. So which rate do I use? This will probably become a lot more clear in your, when I, kind of break some of the questions out for you for your homework. But if you just see annual rate, it's fair to assume that you can just use your nominal rate, that you don't have to use an effective annual rate. But if you see anything that says anything different than annual, semi-annual, quarterly, daily rate, you know that the effective annual rate needs to be used, okay? So let's show you an example here. So it says, what's the future value of $100 after 3 years under a 10% semi-annual compounding or a quarterly compounding, okay? So this question kind of tips you off here. You could have solved for the future value of $100 over 3 years at 10% if this was just an annual rate. You would have just plugged it right in there to solve for the future value. But because this is semi-annual and they want us to solve for the quarterly interest rate or effective annual rate, we need to take an extra step here. So let's come down here. So let's skip through a couple of these slides here, and let's just get straight to the point with slide 37. So you can go through these other slides and draw your timeline, and you can do your algebra equation if you want to. But the simplest way to figure this out is to find out what your effective annual rate is and then plug it into your calculator. So from that question, it said we have 3 years to invest this $100 annuity, and we're trying to find the future value of it, right? But we are investing it semi-annually, okay? So instead of plugging 4 in for my IY, I need to find my effective annual rate using my equation. So we're going to take that same equation from the previous slide, and we're going to plug in a nominal rate of 4%, and our M, because it's semi-annual, is 2. We'll plug that in, and we'll get that effective annual rate of 4.04%. And that is what we're going to use for our IY in our calculation here. Okay, so we can clear out a calculator. So it's a 3-year annuity. Our effective annual rate is 4.04%. We weren't given a present value, so we have to assume that it's 0. We don't have any money today. We are investing $100, so it's a negative cash flow, and we'll plug that in for our payment. And then we're going to click Compute Future Value. So you get that $312.28 there. So my $100 for 3 years every year is really worth $312.28 if I compound it semi-annually. Okay? You can also solve this annuity. Again, you can do it the same way. You can also find the present value of that annuity just like we did in the first lecture. And all we're switching there is instead of solving for future value, we're solving for present value. We're not given a future value, so we plug that in as 0. And we solve for our present value, and we find out, given that semi-annual effective rate, that our present value of this $100 3-year cash flow stream is worth $277.30 today. Okay, so if you guys need help working back through how to solve those annuities, I would go back to the first part of this lecture to run through that on your calculator. Okay. So the very last piece that I want to talk to you about is loan amortization. So loan amortization or amortization schedule, you might hear this in banking, you might hear it about your student loans if you have them, maybe if you have a car loan. And basically what it's saying is we're trying to figure out, when you buy a car, you have one payment, right? You pay $360 every single month. And it's not any big thing to you. You just make a regular payment every single month and, for 5 years to pay off your car. But what an amortization schedule does is it breaks down the principal and interest of each of those payments, okay? So the example here, and we don't just use them for auto loans, we use them for your mortgages, for your student loans, for business loans. It's an amortization schedule. It's good for any kind of loan. And it simply takes our full payment and it breaks down how much of that payment do we pay in principal and interest. So if you're not familiar with a bank loan, let me break that down for you really quick. So if you come into, let's say, my bank and you want to buy a car for $35,000, I am going to loan you $35,000, right? That's what we call principal. That is just the cash that I gave you to purchase, involved in the transaction, whatever you're doing. The interest, however, is how the bank makes money, and that is the additional amount of money in addition to the $35,000 that you pay back to the bank to use their money, right? So the payment, that $360 payment for the $35,000 car, you'll notice, has partly principal, is partly paying down the $35,000, and the other part of that payment is going back to the bank as their payment for letting you borrow their money, okay? That's the cost of a loan. That's the cost of bank money. So you may not believe it, but here in finance, we can use our financial calculator and we can construct a loan amortization schedule from that, okay? So the example that they give you here is they say construct an amortization schedule for $1,000 at a rate of 4% with 3 equal payments. So let's break it down and make it more simple. Basically, the bank is going to give you $1,000 at a rate of 4%, and you're going to make 3 payments to pay them back. Okay, so it could be years, this could be 3 months, however you want to think about it. It doesn't matter, but you're going to make 3 equal payments on this $1,000 loan, okay? So the first part of this question is we have to find out actually what that payment is. To build this amortization schedule, we have to figure out what the payment is. So this question is just like the ones you solved earlier in the first part of this lecture. So we're just going to break it down, okay? So let's clear out our calculator. So we know that this loan is $1,000 and we're going to make 3 equal payments. So our N is going to be 3. Now earlier I told you think about N in years. Your N is simply a period. Your N could represent anything. Your N is just a period. It's not necessarily a year. So for the terms of this, it's just 3 payments, okay? So N is 3. We know that we're borrowing the money from the bank at a rate of 4%. So I'll plug that in. Now, this question's a little bit different because you have to think about your cash flow and not in the sense of a negative, but think about where your cash flow stands today. And you can think about this in terms of the bank. You can stand in the bank's shoes or you can stand in your own shoes. So in this question, we are going to take the viewpoint of the bank, okay? So my present value, the present value of this loan today is $1,000, okay? And you'll notice that the future value in this question is 0 because the idea is in 3 payments, you're going to pay this loan off. So the future value, well, there won't be a future value because you will have paid back the loan, okay? So the present value is 1,000. So in this instance, we're the bank and we're going to give away $1,000. And by give away, I mean it's a legal contract that you'll get paid back for, but bear with me. So we'll plug in $1,000. That'll be our negative, and we're going to plug that into our calculator as our present value, okay? We're solving for that payment, so we're going to skip over that input, and the idea for this loan is that in 3 payments, we won't have any value because everything will have been paid back at that point. So we'll have a 0 future value, and then we're going to go ahead and compute for our payment. So the payment, if you're in the bank's shoes, is positive because you're giving out $1,000 today, but you're going to start receiving $360.35 back, okay? So that's our payment, and that's how we're going to build our amortization schedule, okay? So let's go to slide 41 here. So that was step 1, is finding our payment. Step 2 is finding the interest paid in year 1. So I think it's easier to actually look at the amortization schedule first and then go back through each of these steps to calculate that. So let's go to slide 44 and let's actually look at this amortization schedule, okay? So the amortization schedule, let's go left to right. We have the year, straightforward. We have our beginning balance. The next column is our payment. So the beginning balance of this loan was $1,000. We know that. So in year 1, we can just straightforward plug that $1,000 in. We just solved for our payment, and we know that that payment is going to be constant for the next 3 years, so you can automatically just fill that in, okay? So that's the easy part of this amortization schedule. The next part that we need to solve for is our interest. So we have this arbitrary $40 sitting in there that we need to find out how we calculated that. So the interest that you pay on a loan is calculated by your balance on the loan, okay? So we're going to shoot back up here to slide 41, and step 2 is finding the interest you paid in year 1. So you do that by taking the beginning balance and multiplying it by the interest rate on the loan, okay? So you take that by taking the beginning balance, that $1,000, and multiplying it by the interest rate on the loan, and that's where that $40 comes from. So I'm going to jump back to slide 44. So we automatically know that at a 4% rate with a balance of $1,000, our interest is $40. Well, what is that $40? That $40 is the breakout of this payment. So $40 of this $360 is going back to the bank in interest. And then you can bet that the principal is pretty straightforward to calculate from there. You take your payment minus your interest to get your principal. So if we go back up here to slide 42, you'll see that we take step 3 and we find the principal repaid. Sorry guys. We find the principal repaid in year 1. And so straightforward, we take that payment, we deduct the interest we're paying back to the bank. So $320.35 is going back to the principal, that principal $1,000 I borrowed from the bank, and it pays that principal down. So if we go back to our amortization schedule here, our ending balance is simply our beginning balance minus our principal, okay? So the beginning balance and the ending balance are simply dealing with principal, that $1,000, that's all it's monitoring. In between here, this payment is taking into consideration this interest, okay? So the next year, year 2, you're going to take the ending balance, that 680, and that'll be your beginning balance in year number 2, right? We know our payment is still the same. It's still that 360 figure. So we're going to take the beginning balance, we're going to take that $680, we're going to multiply it by 4% because that's the rate on our loan, and we're going to get an interest payment of $27, okay? So that's step 2. Step 3, we're going to take that payment, this 360 payment, and deduct $27 from it to get the principal of $333, okay? So we'll deduct, stick with me, we'll deduct that $333 from the beginning balance to get our ending balance, and so on until you reach the end of your amortization schedule. And the whole point of this amortization schedule, to know that you've done it correctly, at the end of your, whatever your payment structure is, at the end of the amortization schedule, you want it to equal 0. And that was just like our future value that we plugged in earlier, because at the end of those 3 payments, you will have paid off the loan. You will not have a principal balance anymore. So the other nice thing that this chart does here is below, you'll notice that, and you might have caught on to this when you were calculating your payment, well, you're borrowing $1,000, but your payment's $360, so you're paying well over $1,000, right? That's correct, because that $1,000 is encompassed here, but $81 of that is interest that's going back to the bank. So anytime you borrow money, you pay money back to whoever is issuing the debt for you. So the very last diagram here is pretty helpful if you're a visual learner. So you'll notice up here in the light blue we have interest, and in the bottom we have principal payments. So this is what we call top-heavy or front-end amortization schedule, and all that means is if something is fully amortized like this is, that the interest is going to be very heavy in the beginning, or you're going to be paying a lot of interest on your loan because your balance is the highest at the beginning of the loan. And as you start to pay down that principal, your interest payment becomes less and less. So if you have student loans, you'll notice that when you first get out of school, you pay quite a bit in interest because you are paying down the principal, and your principal is very high when you first start paying. It's just like a mortgage. If you've ever paid a mortgage, it's not past year 10 or 15 that you really start to see a dent made in your principal balance. So it just means that it's interest heavy. Because of the balance of that principal, you guys will pay more in interest until you can start to kind of knock some of that principal out to the bank. Okay guys, that is chapter 5. I know that's a lot of information. I hope it's helpful to stop and start this lecture and rewind it as you see fit. I will also be uploading some exercise and practice problems for you for your homework.